Let's now turn our attention to the discussion of a very important topic in the field of strength and conditioning, and that topic is program design for resistance training. Effective training programs involve the coordination of many variables in a systematic fashion that enables the body to adapt and performance level to improve. When focusing on the resistance training component of a comprehensive training program, it is helpful to approach the task one program element at a time, keeping in mind the primary principles of resistance exercise prescription. And those principles include specificity, overload, and progression. Now, in the case of resistance training, specificity refers to aspects such as the muscles involved, the movement pattern, and the nature of the muscle action, also known as the speed of movement or force application. Specificity also relates to the athlete's sport season. Overload refers to assigning a workout or training regimen of greater intensity than the athlete is accustomed to. The application of this principle in the design of resistance training programs involves increasing the loads assigned in the exercises, increasing the number of sessions per week, adding exercises or sets, emphasizing complex over simple resistance exercises, decreasing the length of the rest periods between the sets and exercises, or any combination of these or other changes. And finally, progression, when applied properly, continues producing higher levels of performance and promotes long-term training benefits. Progression is based upon the athlete's training status and is introduced both systematically and gradually. Well-designed resistance training programs are based on the application of sound principles during each step of a process referred to as program design. Designing a resistance training program is a complex process that requires the recognition and manipulation of 7 program design variables. And you see these program design variables listed here. First being a needs analysis, exercise selection, next would be training frequency, then exercise order, very important in terms of training load and reps, and we'll discuss that later. And finally, exercise volume and rest periods. Now, for this module, we're going to come back to 3 different athlete scenarios and basically apply the 7 resistance training program design steps to these 3 athletes. So this is something that we'll do in class really to apply this information, so you will not see this discussed further within the video. But our 3 athletes that we'll discuss, first being a 20-year-old female collegiate basketball center at the beginning of her preseason. Next we have a 28-year-old male professional American football offensive lineman, beginning of his off-season. And finally a 17-year-old male high school cross-country runner at the beginning of his end season. And for each one of these 3 athletes, each athlete is well conditioned, has no existing injuries, and has been cleared for training and competition by the medical staff. So for the sake of this video, we're going to skip over the needs analysis step, and we'll discuss that in class next week. So after we perform the needs analysis, the second step here is exercise selection. So selecting resistance training exercises requires knowing several things. This includes the movement and muscular requirements of that sport. And again, this goes back to the movement analysis performed as part of the needs analysis. We also have to know the athlete's exercise technique experience. And if there's any doubt in the athlete's experience, have the athlete demonstrate the exercise and provide instruction and feedback as needed. So for example, if we're looking at exercises such as the forward step lunge or the barbell back squat, you see the improper exercise technique on the left here for the forward step lunge and right here for the barbell back squat. And what we're looking for here for the lunge is taking a long step and having the knee basically tracking over the toes, hands on the hips if they're not holding any dumbbells, torso is erect. And here for the barbell back squat, again, we're looking for the same thing, kind of hinging at the hips and having the knees here over top the toes as the athlete is lowering the weight. So again, proper exercise technique is going to be important here for overall performance, but also safety of the individual performing the lift. We also have to know what resistance training equipment is available. So for example, if you only have machine exercises at your disposal in your facility, then you would not be able to do free weight exercises. Or if you don't have, let's say, an Olympic lifting platform, then that would prevent you from including Olympic lifts in that individual's resistance training program. Another factor we have to consider is the amount of training time available. So athletes and individuals have several other responsibilities in their lives. So when time is limited, then it may be wise to prioritize time-efficient exercises. So for example, you may have the athlete perform a machine leg press versus a barbell back squat when time is limited. And it's much quicker to change the pin on a machine leg press rather than it is to change the plates for an exercise such as the barbell back squat. So when we're talking about exercise selection, we can really break down resistance exercises into two main categories. So first we have core exercises. Those are the ones that recruit one or more large muscle area, involve two or more primary joints, and receive priority because of their direct application to the sport. So these exercises include the deadlift, power clean, back squat, front squat, a variety of different presses, both bench press and overhead press. We can subdivide core exercises into structural exercises, which are simply the core exercises that emphasize loading the spine directly or indirectly. So again, going back to back squat, front squat, deadlift, overhead presses. Those would be examples of structural exercises. And another subcategory of core exercises are power exercises. And these again are structural exercises that are performed very quickly or explosively. Think of the Olympic lifts such as the power clean. And these are assigned when appropriate for the athlete's sport-specific training priorities. So if the athlete's priority or goals are to improve their muscular power, then it would be wise to include some power exercises in that athlete's overall program. Our second major category in terms of resistance exercise selection are the assistance exercises that recruit smaller muscle areas, involve only one primary joint, and considered less important in terms of improving sports performance. However, these assistance exercises may be more commonly applied in an injury prevention or a rehab type of program. So these exercises include something such as a leg extension or leg curl for the lower body, or like the tricep extension or the bicep curl for the upper body. What you see in this table is a list or examples of movement-related or sport-specific resistance exercises. And what we know about including sport-specific or movement-related resistance exercises in a resistance training program is that the more similar the training activity is to the actual sport movement, the greater the likelihood that there will be a positive transfer to that sport. So what we see here in terms of the movement pattern, again, going back to the needs analysis, this would be part of that movement analysis. But if we're talking about an athlete where a lot of movements include ball dribbling and passing, such as basketball, you see some related resistance exercises here, again, mimicking those sport-specific movements. If we're talking about athletes that may involve a lot of running or sprinting, so you see some related exercises there for those specific athletes. Athletes that do a lot of throwing or pitching, you see some related exercises there. But again, the key here is doing your best to try to choose resistance exercises that mimic the primary movements in that athlete's sport or event. So training frequency is another one of our program design variables. What we see in this table is a resistance training frequency based upon an athlete's training status from beginner to advanced. So if we have an athlete who is new to resistance training, typically they would have a lower frequency of training, allowing for greater recovery between training sessions, whereas an advanced athlete, an advanced resistance trained athlete, such as our American football lineman scenario, then it would be more appropriate to have a greater frequency of training, maybe in the range of 4 to 7 days per week. The frequency of resistance training can also be based upon the athlete's sports season. So what we see in this table is, again, frequency guidelines for a trained athlete based upon different seasons of his or her sport. So for the off season, where there's a greater focus on resistance training and other types of training, we have a greater frequency in terms of days or sessions per week compared to something like the in season, where the athlete is focusing on competition, or even the postseason, the active rest season, where the athlete is recovering from the stress of the recently completed competitive season. What's important to remember here is that training frequency is influenced by the overall amount of physical stress being placed upon the individual. So for example, athletes who train with maximal or near maximal loads as part of their training regimen typically require more recovery time before their next training session compared to athletes who train with a submaximal load. We also have to consider the effects of other training types when talking about training frequency. So this includes other aerobic or anaerobic training, such as sprint training or plyometrics. Any sport practice that definitely places an added stress on the athlete or individual. And does the athlete or individual have a physically demanding occupation that also places added stress on their body, thus requiring more time before their next training session? So many individuals and athletes may choose to do a split routine. So what we see here in terms of various examples of common split routines. So for this first one here, you got training day 1 and 2. Day 1, focus on the lower body. Day 2, focus on the upper body. So the athlete may split up their routines in this manner, with the resulting training frequency being 4 times per week. So performing lower body exercises on Monday and Thursday, and upper body exercises on Tuesday and Friday. Another common split routine would be doing like chest, shoulders, and triceps on day 1, lower body resistance exercises on day 2, and focusing on the pulling muscles, the back, the traps, and the biceps on day 3. So you see here with this resulting training frequency being 5 days per week, doing the chest and shoulders on Monday and Friday, the lower body on Tuesday and Saturday, and the back in this specific week example on Wednesday of that given week. We can also break it up and maybe doing alternating movements, so chest and back one day, lower body one day, and the shoulders and arms on that third day. And again, this would result in a frequency of resistance training of 6 times per week.